This is Radio TV Phono Nut, and what we have here is an RCA Institutes AM tube radio chassis from the 50s, based on the date codes on the tubes about 1957. Now, this was something that you would have built if you took the RCA correspondence course on radio and television repair. Generally, these had no cabinets. You just built the bare chassis, and if you wanted to make a cabinet for it, that was on you. So we have our off-on volume knob here, and our tone knob here, and our direct tuning here. No dial string to worry with, thank goodness. This is a 6-tube chassis that contains a mix of 7-pin miniatures and the older style octal tube. So we have a 6BA6 RF amplifier, 6SA7 oscillator and mixer, another 6BA6 for the IF amplifier, 6AT6 for the first audio and detector tube, 6K6 audio output, and a 6X5 rectifier tube. And as you can see, this chassis is power transformer driven, which is a bit unusual. Most of these correspondence school radios used a series string hot chassis, but RCA seemed to be a step above in that regard. As you can see, the speaker is pretty much roached out and is eventually going to have to be replaced or reconed. And looking at this, it looks like somebody added a switch and a terminal board here to allow connection to a external speaker. Likely they wanted to connect this to a bigger 12-inch speaker in a cabinet for better fidelity. Just glancing at the underside of the chassis, I don't see anything that just blows me away. I see it's got a bunch of these green Sangamo capacitors that are probably leaky. And on that note, the person I got this from said that all it does is hum when you turn it on. So I think based on that statement, we can pretty much know that the problem is most likely this filter capacitor can here. We'll check that in just a few minutes. Here's the pilot lamp. You might remember several years ago I showed a video of another chassis very similar to this that someone had housed in a very crudely made cardboard cabinet that they made out of a box. The RCA Institutes tuning knob was missing from mine, and I've been looking for a knob for years, and then this chassis popped up on eBay for a cheap price, so I just said, what the heck, I'll just go ahead and buy another radio. I see a hole on the back of the chassis that looks like where an RCA phono jack could have been mounted in case you wanted to use this radio as an amplifier for your phonograph or whatever. So obviously this is the tuning condenser. This here is the antenna coil that our long wire antenna is connected to. This looks like the first IF transformer, second IF transformer, audio output transformer for the speaker. With this being a kit radio, at least everything is bolted to the chassis, so if I have to replace anything that is attached to the chassis, I can simply unbolt it instead of having to drill out rivets. Looks like we have a filter choke in the power supply, which is a nice touch. Where's the oscillator coil? That looks like our oscillator coil right there. So yeah, once this is serviced and aligned, it ought to be a good radio. Okay, we're plugged in, turned on with about 60 volts AC input. I'm getting absolutely nothing, no current draw, no anything, so we obviously have an AC input issue here. And the main three things that could be is an open power cord, open power switch, or an open primary winding on the power transformer. And that's easy enough to find with an ohm meter. Well, for one thing, these power plug prongs look pretty crusty. but we have our own meter connected across the plug, and the radio switched on. And as you can see, we have an open circuit here. Okay, meter connected to the black wires, the two black wires. That's the primary winding of the transformer. And the meter says we have, what does the meter say we have? We have 12.8 ohms, so that's good. Okay, measuring across the power switch, looks like we have an open circuit, so the power switch is the fault. But before I write it off, I'm going to spray some cleaner in it and see if that will help it. I've seen some of these, the contacts get oxidized, and spraying some cleaner in them will cause them to make contact again. Okay, I've sprayed both of the controls with cleaner, and unfortunately that didn't help our switch situation, so for right now we're just going to bypass the switch, and then we'll decide what course of action that we're going to take later on down the road once we get the radio to play. You know, measuring across the power plug, I'm still getting no resistance. Well, this meter already, the test probes are already starting to not make good contact, and the jack on the meter, I turn the probe a little bit where it plugs into the meter, and it started making contact. Now we're getting erratic continuity all over the place across the power plug here, but that's no surprise given how gunked up this is. Alright, rechecking the power switch. I'm reading, it's all over the place, 1.1 k ohms. Alright, I'm going to put some juice to this. Sometimes putting juice to them will cause those contacts to experience a reality check, and they start working better then. Alright, that's good. We now have power. Running about 60 volts AC input. No excessive current draw on the meter. Alright, still at about half AC input, still no excessive current draw. Checking our voltage at the cathode of the 6X5 rectifier tube, and we're getting absolutely nothing. Alright, now let's check the high voltage coming out of the power transformer. Generally you'll have about a 600 to 700 volt center tap winding, with the red with the yellow tracer being the center tap, and the two red wires being the outer ends of the winding. The center tap in this case connects to chassis, and then the two red wires connect to the plates of the rectifier tube. So we have our meter set up to measure AC. Meter ground connected to meter negative connected to the chassis. Alright, with full 120 AC applied, I have 260 volts from one side of the winding to center tap. Well, 264 actually, but we'll just say 260. Okay, 270 on the other side. Alright, let me just double check the other side one more time, since I did alter my AC input voltage here. Okay, 269 on the other side, so as far as I'm concerned, this power transformer is healthy. And 7 volts on the filament winding, so yeah, this transformer is plenty healthy. Okay, I checked the rectifier tube, and it checks good, but we're still not getting any B+ voltage at the cathode of the rectifier tube. I then took an ohm meter measurement from the cathode of the rectifier tube to ground, and it was way up in the mega ohms. So that tells me these filter capacitors are probably open. Alright, black lead of the ohm meter connected to chassis, which is circuit ground. Do a meter test by touching the positive lead to the chassis. We're getting 0 ohms, so the meter is working. Now, we have 3 sections of this capacitor, this section, and this section, that have to do with the power supply. This section back here is the cathode bypass for the audio output tube. We don't have to worry about it right now. Alright, coming off of the cathode of the rectifier, we go to this first section. And as you can tell, we're reading absolutely nothing now. Second capacitor section, same thing. And third capacitor section, same thing. Now this effect is easier to see on an analog meter than a digital meter, but you can still see the effect on a digital meter. Had this capacitor been good, what would have happened? Whenever I touched my positive meter probe to the plus terminal of the capacitor, the meter would have gone towards 0 and then slowly climbed back up. Well, now we're reading, what are we reading? 13 megohms. And it's slowly increasing, so yeah, for all intents and purposes, this capacitor is bad. That's interesting. Now we have about 57 volts on the cathode of the rectifier with about 65 volts of AC input, but no noise from the speaker. Let me make sure this speaker switch is turned on. Obviously it was not turned on. Not getting any reception. Okay, so we were basically just chasing our tail there. I don't know whether our alligator clip leads were not making good contact or what. That's certainly highly possible, because these newer generation of clip leads are nothing to write home about, and I've had to fix many of them because of intermittent connections. But anyway, let's conquer one problem at a time. We know the electrolytic filter capacitor is bad, and we're going to have to replace that. And this may give us a time to try out something new here. It just so happens that today in the mail I received this care package from one of my viewers who has sent me some things in the past. And he sent me something that will be of use to us, I know. Come on out of there. What these are called, Adaptacap. And what these are pre-made little circuits that you can install in place of an old can type capacitor and install regular modern day capacitors on top of the circuit board here, and then make your connections, and it'll be all nice and neat looking. So I think we're gonna see if we can use one of these in place of this capacitor here and make it look neat and not have to mount terminal strips under the chassis, and there's not really much room right here to do that anyway. So let's give this a shot. And the first thing you want to do before getting hog wild with your soldering iron and removing stuff is to take note of where everything goes and draw a schematic if you need to. Okay, I drew this out the way it's wired, but I question if this is correct or not. So coming off of the cathode, we have our first filter capacitor and our input to the filter choke, and there's nothing coming off of there to any other part of the circuit, which I'm okay with that. Coming out of the filter choke, we have another filter capacitor here, and then we tap off of there, going to the IF and front end circuitry, and then we also connect to a capacitor that connects between the plate of the output tube and this point right here. Now that's for tone compensation and to prevent arcing inside of the output tube. Now this is where it gets a little funny. We go through a 1K ohm dropping resistor, and coming off of that point is where we connect to the audio output transformer primary winding, and also to the screen grid of the audio output tube. Granted, I haven't seen every radio schematic ever published, and I don't have a schematic on this radio. Maybe I need to try to find one, but generally speaking, This point here before the 1 k ohm resistor is going to be your highest B plus voltage point, and I would think this point would be what connects to the audio output transformer in the screen grid of the output tube, and this point over on the other side of the 1 k ohm resistor should go to the IF and front end circuitry, but maybe I'm wrong. But like I said, just drew it like they had it. I'll try to find a schematic on this and see what's really correct. That's the thing, when you run into stuff that's home built, you never know when you're going to find mistakes, and when a beginner is building something, then it's easy to make a mistake. In fact, it's sometimes easy to make a mistake for those of us who have been doing it for 30, 40, 50 years or more. Now, if you'll look beside each terminal of the capacitor, you'll either notice an actual cutout in the bottom of the capacitor that designates a symbol such as a square, triangle, half circle, etc., or you'll notice said symbol just simply etched into the phenolic bottom of the capacitor here. And if you look on the capacitor body, that symbol corresponds to what value this capacitor section is. For example, the symbol that's marked, the terminal that's marked with a square, might designate a 40 microfarad 450 volt capacitor. The symbol marked with a triangle might designate a 20 microfarad 450 volt capacitor section, etc. And if you look on the capacitor body, if I'm seeing this correctly, 40 microfarad is the half round symbol, and it looks like 20 microfarad is the square, and it looks like another 20 microfarad is the triangle, and then a 25 microfarad is just a no symbol at all, or just a dash there. And what's the working voltage here? I can't quite make it out. Okay, it looks like 300 maybe. That's fine. We'll use 450 volt ones to replace them. So the square is 40 microfarad. The half circle is 20 microfarad, even though that doesn't look like a half circle. And then the triangle is also 20 microfarad, and the section with no symbol is a 25 microfarad low voltage cathode bypass capacitor. So now that we know where everything is, we can proceed with disconnecting everything, and then we won't be lost when it comes time to reinstall the new capacitors. Alright, physically disconnected, but physically getting these tabs lined up so I can get the capacitor off the chassis can sometimes be a pain in the butt. Alright, here's our old capacitor. Industrial Condenser Corporation. Royal Lytic capacitor. Well, gee, I hope it won't be a problem with me putting electrolytic capacitors in there. So yeah, 40 microfarad, 20 microfarad, 20 microfarad, all at 300 volts, and a 25 microfarad at 25 volts. Case is common negative, long life, and date coded the, looks like the 9th week of 57. And what VDCW stands for is voltage DC working, or working volts. Alright, now I had to break off a couple of the tabs to get this thing out of the mounting thingy-madoodle. It was wanting to be very difficult, but since I'm throwing this away anyway, I wasn't worried about it. Now we need to simply unbolt this bracket and see if one of our adapter cap brackets will fit on here. And if it does, we'll try to use those, and I'm very appreciative of those. So to the person who sent them, thank you for sending them, and they will go to good use over here. Alright, here's the original mounting bracket removed, and I'll save that in case we need it down the road for something. And on that note, there are a couple of companies who still make these multi-section can-style capacitors, and I think at least one of those companies makes our custom capacitors for whatever you need, but as you might expect, they're pretty pricey. So You know, if you're working on a piece of equipment that you're a stickler about the appearance of it and keeping everything original looking, then yeah, I would say go with the remanufactured can capacitor. But otherwise, just either leave this one in place leave the old one in place for looks and wire a terminal strip under the chassis to mount the new capacitors, or use one of these adapter cap plates to mount to the chassis and put your new capacitors on that. Alright, I'm looking at this under my magnifier since this is the first time I've ever used one of these little doohickeys, and just want to kind of see what everything is. As you can see, they have a trace that runs along here and back around here. That looks to be the common negative point where all your capacitors and other things that need to be tied to ground will go to that point. And you see they have the plus connections marked here, and these also have the little symbols on them: square, half circle, triangle, and then nothing at all here. So you can line everything up just like it was on the original capacitor. And you notice they have several different hole combinations here to accommodate the various lead spacing depending on what the physical size of your capacitor is. So this side with the symbols on it should face the underside of the chassis, so the symbols can be seen just like with the old capacitor. Okay, here's our 4 new capacitors mounted on the board here. We have it situated so when it's mounted in the chassis, someone looking at it from the underside can see the symbol designations, which they have them on both sides. And the top side here has the adaptacap.com web address. Keep that visible, so if somebody works on this radio after I do, gets a hold of it and starts peeking around on the inside, they'll want to know where this little device came from, who made it, then they can see it on there. Now, I made a boo-boo. I accidentally installed the cathode bypass capacitor backwards, and sometimes getting the holes cleared out on these double-sided boards can be a bit of a chore, but I got it pretty good. It's not perfect, but it'll do. I've trimmed off my negative leads. I have not trimmed off the positive leads all the way yet, and that's just in case I need to attach something to them. I don't think I will. I think I can make my attachments in these extra holes here. Okay, one thing we need to remember to do when mounting this, the metal chassis of this radio is circuit ground, and the metal can of this capacitor is common ground, and it needs to be, of course, connected to the chassis. Now, they accomplished that by, where's my mounting thing here, having the metal can capacitor mounted to this metal mounting bracket thingy-madoodle, and then, of course, the metal mounting bracket was connected to the chassis, which, of course, provided a ground path for the metal can of this capacitor to chassis, which is circuit ground. Now, our little adapter cap plate here, we do not have a connection from these outer mounting tabs here, bolt holes, whatever you want to call them, to ground here, and the reason we don't is because there are some instances where it's not desirable to have the negative terminal of the capacitor connected to the chassis, and in such cases they'll use a phenolic mounting bracket to insulate the capacitor can from the chassis, but in this case we need our capacitor negative terminal here to be connected to the chassis, so we're going to have to run a wire from our negative terminal and solder it to the chassis, or I could solder a piece of hookup wire to one of these unused negative terminals on the board here and run it around and solder it to this this mounting hole here, there is a trace here that will allow us to do that, and then we can bolt it to the chassis and it ought to remain grounded. So I think that's what we may do, and then it'll be just like the original was and look neater. Okay, this is an aluminum chassis, so I can't really solder to it, so we're going to have to ground this to the chassis. Like I said, just run a negative lead from here, wrap it around here, solder it to this trace, and then bolt the whole thing to the chassis, and then it should be secure. Alright, there's our little extension to make this ground. And I goofed again. I messed up and didn't orient these in the position that they were originally, but we'll make it work. I think our leads are still plenty long enough to stretch over, and if they're not, we'll just add longer ones. There's more than one way to skin a cat, because I'm not unsoldering all this and turning and moving the positions around. Just have to make it work like it is. Alright, here we are physically mounted. I had to remove my ground strap because the little solder bumpy was keeping the screw from going down far enough where I could screw the nut onto the end of it. So we're just going to have to run a ground wire from one of the ground connections on here to a actual soldered ground connection in the radio, and that would probably be better anyway. And we'll do that tomorrow. It's getting kind of late, and I'm getting kind of tired of looking at this thing for the day. So we'll call it a night, and we'll get back on this some other time. Okay, I decided to pull this back out and reorient the capacitors where they'd be in the same positions as the original ones. That way I can more easily connect everything back up under here. Okay, there we are physically mounted to the chassis, and that looks pretty good. And based on a video I watched, the outfit that's building these is, I believe they're working on some kind of cover that you can put over this and will make it look like an original filter can, but as it is, I think this looks pretty good. Okay, this cathode resistor is marked 470 ohms. It measures 484 ohms, which that's within the plus or minus 10% tolerance range, so that resistor can stay. Okay, we have our ground connections made, cathode resistor, and this mica capacitor here, and then we added an extra wire to go back to ground this capacitor assembly to the rest of the circuit. So I have 1 meter lead connected to chassis, and we'll just go around. That's good. That's good. Good. Get on there. That's good. Good. That's good. And that's good. So everything is grounded as it should be. Okay, before I start hooking up the positives, I'm going to go attempt to find a schematic on this radio and just double check my theory, because I just don't believe that whoever built this had the power supply wired correctly. Like I said before, they have the IF and converter and RF stages supplied directly off of the filter choke, and then at the other end of the 1K ohm resistor is where they're getting the voltage for the audio output stage, and that just seems to be backwards from the way it's normally done. Generally, the audio output stage is going to need the highest voltage, and the front end other stages of the radio will operate off of lower voltages. But just to be sure, I'm going to go try to find a diagram on this and see what it has to say. And if the diagram shows it this way, then that's the way we'll connect it. And if I can't find a diagram, I'll just connect it the way I think it should be, and that'll be it. Okay, I had no luck finding a schematic for that radio, and the other chassis I have is buried somewhere, but I remembered I had done a video on the other chassis. So I looked at it, and fortunately I showed some shots of the underside, so I looked to see how it was wired. And on that particular chassis, it looks a little more believable. They have the audio output transformer connected to the right after the filter choke here, and then a 0.01 microfarad cap across the transformer. But they have the B+ voltage going to the front end circuits also taken off of that particular point. I need to look at the radio and see if there's any more dropping resistors there for that particular area. And then this 1K ohm dropping resistor with a third filter cap on the other side. The only thing it's going to in my other chassis is the screen grid of the audio output tube. So, and since that chassis works, then I suppose we'll just wire this one that I'm working on today just like the other one was, or is. Alright, I got everything in here. It looks like total crap. That's just the way it is. It's one of those situations where there's too many things that need to go to one place and not enough places to put them. So it is what it is. In fact, I'm almost to the point that if this thing doesn't work, then I can pull the knobs off of it and put them on my other chassis that does work and throw this thing in the garbage. And it's not doing a darn thing. I'm hearing a very, very faint hum in the speaker, and that's it. So what's wrong with it? And as far as these kit radios go, you never know if they ever worked right to begin with, and oftentimes there was never just a full schematic published. You got bits and pieces of a schematic and whatever lesson you happen to be studying at the particular time. I know that's what a friend told me about a Bell & Howell TV that he built in the early 70s. You built the TV over the duration of the electronics course. You didn't get just a full schematic to the television. Okay, with about 90 volts AC input, I'm getting about 54 and 57 volts on the plate and screen grids of the output tube, which is way too low. I'm getting about 3 volts on the cathode, which tells me the tube is conducting a little bit, but for whatever reason our B+ voltage is lower than it should be. Alright, I'm checking from the control grid of the audio output tube to ground for a resistance measurement. And what are we reading? 443 k ohms. So that tells us that resistor is good, because there's generally like a 470 k ohm resistor between the control grid and ground. And then we have this coupling capacitor. I'm going to take one end of that loose and check it. Alright, at the cathode of the rectifier with full 120 AC applied, I have 210 volts. I can live with that. Alright, on the output tube, I've got 163 on the plate, 171 on the screen grid, and about 9 volts on the cathode. And I indeed get a slight buzz from the speaker when I touch the control grid of the audio output tube. Now this capacitor disconnected. We have a meter that's not making contact. We have 178 volts on the B+ side of that capacitor. Seems a little high. And then on the grid side of the capacitor, we do indeed have a positive voltage that's flipping around, but shouldn't be enough to cause the audio output stage to go berserk. However, that capacitor will get replaced, but I am concerned about 178 volts on the plate of the 6AT6. That does seem a little excessive to me. So you can see we have a 100 k ohm plate load resistor on the 12AT6. Let's see what voltage we have on the plate side of it. The B+ side of it. 168 volts. Now let's see what we have on the plate side. 168 volts. So what does that tell you? That tells us our 6AT6, for whatever reason, is not conducting. Okay, I see the problem. After examining the bottom of the tube sockets and where everything goes, somebody has transposed the IF amplifier tube in the 6AV6. So the 6AT6 should be here and the 6BA6 should be here. And that makes sense with the 6AT6 being closer to the audio output tube. I thought that looked a little funny whenever I was first giving this chassis the once-over. Okay, that sounds a lot better. Now, as you can tell, we just have a good capacitor in series with the old coupling capacitor just for testing.
It's devolving into... Well, the point of sports is to win. No, obviously. I mean, you guys are great, you know, you have great moral compasses. I don't. I want trouble loss. I want sunshine! Alright? But again...
Let's see what our voltages are. Alright, screen voltage 177, shut up. 177. Plate voltage. If the meter will settle down, 169. Let's see what we have on the plate of the 12AT6 here. 93 volts, that's more like it. 12AT6, 6AT6, whatever. And as bad as I don't want to do it, I think before we finish this, I'm pulling this filter capacitor assembly back out, and I'm going to manufacture some little terminal lugs to put on there that will allow me to connect everything up without this jake leg looking mess. Okay, that's all the paper capacitors changed, and I just tested these on the old school capacitor tester. The two Goodall Marblite caps still check fine, no leakage at all detected. These 4 Sangamo capacitors, they are a tad bit leaky. Even though they're not nearly as bad as some that I've seen, they still stimulate the neon bulb indicator on the capacitor tester. But we'll throw them all in the box of old capacitors that I've taken out of equipment, and who knows what we'll do with them one day. Probably end up throwing them in the trash.
95.9 FM, 910 AM.
Okay, it's still playing, so I think now we'll take this filter cap assembly back out, and I'm going to make some connectors to put on there so I can neaten up my work a little bit. And then we've got to address this rattling speaker, busted speaker cone. It's ultimately going to be replaced or reconed, but for now we'll patch it up with something to where it will somewhat work okay. Alright, here's the capacitor assembly out of the chassis again, and what we're going to do to make it easier to make our connections is I've got some old resistors that are out of tolerance, big 2-watt jobs with the nice heavy-duty lead wire on them. So I just simply cleared out a couple of holes here on the positive connection, cut off a piece of lead, bent it over into a U shape, stuck it down in there and soldered it. And we'll do the same thing for the other 3 of these, and then of course when we're done we'll clean off all of the rosin flux here to make it look a little bit neater. And then we should have plenty of room here to connect everything that needs to be connected and solder it up, and it ought to be in good shape. Okay, there's our 4 homemade terminals added, and we know a 1K resistor needs to go between these 2 smaller capacitors here, so I'll probably just go ahead and install that now, and we'll use one of our present day smaller, physically smaller 2-watt varieties that'll take up less room. There's our new resistor. Looks like a 1/2 watt, but according to the specs it's actually a 2-watt job. So like capacitors, in many cases resistors have gotten a lot smaller over the decades too. And this mica bypass capacitor from the plate of the first audio tube to ground, you can see That looks kind of sloppy with it mounted on stilts, so we're going to shorten these legs and make it look a little neater. Alright, there it is, and I hope everything's connected good, because if it's not, too bad, because I'm tired of dealing with it. I don't know, it just seems like this new solder you get, it just doesn't flow as evenly as some of the older solder I've had. But it's in there for better or worse, and I had to extend that output transformer lead a little bit because it was a bit of a stretch where they had obviously trimmed it off to have it on the wrong place, and this doesn't feel too good. And see what I mean? Yeah, it just irritates me. It seems like you put 10 pounds of solder on a connection, and there's always one wire that's, for some reason, the solder is not going to flow over, and it's not going to stick, and this is what happened. And for whatever stupid reason, the particular terminal that would have the most connected to it is the one I made the smallest. That should have been the one I made the biggest. Alright, there it is. Everything's connected, and if that's not good enough, too dadgum bad. Hopefully I won't have to pull this cap out for a very long time. And on that note, when you replace capacitors in a piece of equipment, always use name brand stuff and get them from a reputable supplier like Mouser Electronics or DigiKey or someplace like that. And personally, I always try to stick to Nichicon or Panasonic capacitors. You know, don't buy cheap crap on eBay and from some of these back alley parts outfits. Because even some of those parts, even if they carry a name brand, there's a good chance they're counterfeits. As in, they may have the Nichicon or Panasonic logo on them, but inside they contain inferior Chinese garbage. I found out back in my TV repair days, there was some parts outfit, I can't even remember the name of it now, but they had TV parts just for very cheap prices, a lot cheaper than what I was paying elsewhere. And I made the mistake of ordering some STR53041 regulator ICs for the 1990s Zenith TVs and several different types of commonly needed horizontal output transistors. Well, every one of the horizontal output transistors, as soon as the high voltage came up, they shorted. And the regulators, they were DOA. I remember pulling my hair out on the first set that I put one of them in because it would not power up, and I couldn't find out why it wouldn't power up. And finally, I removed the regulator out of another Zenith TV that was known working and put it in the problem child, and it powered right up. So I tested every regulator that came in that batch, and every one of them was DOA. I remember getting a cheap white box generic flyback transformer for a big 36-inch RCA home theater set. Put it in the set, turned it on, watched it for about 30 minutes, turned it off, called it a night. Came back down the next morning, hit the power button, and it sounded like somebody let off an M80 in my shop, followed by smoke and a terrible stench. Yeah, the brand new generic, white box generic, no-name flyback from China or Mexico or wherever it was, popped its guts, and there was a big crack around the case of the transformer with windings hanging out the side. I tracked down an original RCA flyback, installed it, the TV worked beautifully. Same goes for STKs. I haven't had personal experience with this, but I've heard people talk about the cheap knockoff STK parts that either won't work at all or won't last very long, and sometimes they'll blow up other parts when they fail. So, you know, if you can't use the parts, if they're junk, you're not saving anything. So better to spend a few extra cents or a few extra dollars and get some good quality parts that'll hold up, and you won't have to worry about them anytime soon. Oops, I forgot to connect something. No wonder it's not working. yet something else that has to go to this junction here with it's way too congested. If that ain't good enough, too freaking bad. That's 1, 2, 3, 4, 5 things going to that one connection that I didn't make big enough, and there's only so much room you have, so it is what it is. If it's not good enough, somebody can come back 40 years from now and talk trash about me like I talk about some of the stuff I see. Alright, that's what I want to hear, although it sounds like we have some oscillation going on between stations, so I guess that'll be another problem we have to tackle. But it's not going to be tonight. Well, this thing's picking up the weak country station with just the piece of wire on it for an antenna, so that's good, but we still have this oscillation.
100%. With a low-cost quick start.
It's not as bad as some sets that I've encountered, but it's definitely there. Alright, I think I'm going to go with what my instinct told me to go with in the first place and rewire this capacitor like what I'm accustomed to seeing in most other radios, and that is the B+ and voltage for the audio output stage. Plate and screen voltages are taken from the the second filter cap on the output end of the filter choke, and then the output of this 1K ohm resistor and the third filter capacitor will provide our B+ voltage for the front end stages. Having the audio output tube plate voltage and our B+ voltage for the front end stages coming off of the same source, that might introduce some oscillation into the mix, and we don't need that. So let's just try what I thought was right from the get-go, and we'll see what happens. Alright, I moved the power supply connections around, and I think that took care of most of the oscillation. I still enough to know where all this hash is coming from. It seems to be from about 750 to 900, and I get it on every radio. I don't think it's in my house, though, but I'm going to have to walk around with a portable transistor radio and try to figure out what's going on here. Alright, we just have the wire antenna connected to this radio. That's 910 local.
So close to the touch.
1010 local.
My husband, he works in construction at
Need holder stocks are the warmest therm. Independent lab tests prove it. We use a proprietary 3-stage process. Cashier like it.
It looks like an image of 1010 coming in.
On the inside. Country has been fought time again to get this done. Yet we're going to fund that.
Alright, there's a distant station.
How far an extra mile?
Alright, I've got to do something about the speaker before we get any more involved in this. This is so bad sounding. I can't even discern what the radio chassis is doing because of the bad speaker. Okay, I've just connected an external speaker to that jack that somebody was so gracious to provide us with, and part of the oscillation was because the antenna wire was basically right on top of the IF amplifier tube and causing leakage. Alright, let's see what we can get now. Alright, I think that's 670 coming in very weak.
No one can take a break.
Alright, 910.
$1 billion. $4 billion with a B.
1010.
So he can fix his...
That's either an image of 1010 or another station carrying the same programming.
New York City subway, which is, by the way...
In this day and time, it could very well be the latter. I think that's the talk station out of Jackson, Mississippi. Black Gospel Station, a very weak one, I believe, out of Jackson, Mississippi. Is it 13 something? It used to be the old WRBC, I believe. Top 40 station back when AM was decent.
James Harden at a strip club, which is a file.
There's our weak country station.
Fired.
This radio is doing pretty good. We've still got a few more bugs to work out, but we're getting there. Well, I connected this to the outdoor antenna, and the performance seems to be worse with the outdoor antenna than it is with the piece of wire attached to the radio, probably because this antenna transformer needs to be aligned for whatever antenna is connected, and I wish this station would go to a local commercial where I would know if this is an image of a local station or something else coming in.
I've been telling you about pain relief.
Okay, one of the three local businesses that advertise on this station, come on and give me a local spot here.
Price on the premium MyPillow. It was.
Yeah, gotta have the MyPillow commercial.
The premium MyPillow is normally $69.98 through Christmas.
This is one of those stations that I don't even see how it stays on the air anymore.
But you got to use the promo code Mike.
But yeah, this station still has a morning show, which is only a fraction of what it was 30 years ago, and then Mike Gallagher, and then the afternoon full of sports talk, which happens to be the same program that's carried by 1450, and no, the stations are not owned by the same people, and then some talk show at night, and that's pretty much it. Seem to have very few local spots anymore. Like I said, I just don't see how they stay on the air. I mean, I don't even see how they come up with enough dough to pay the electric bill every month. But, you know, if they can make enough to stay afloat, then that's great. I just don't see how they do it. And may I present to you the only time of year that you're ever going to hear music on WMOX radio. On Christmas Eve and Christmas Day, they play Christmas music, and then it's back to the same old boring talk crap. And that was an image of WMOX I was getting, because testing it again today, getting the same exact Christmas programming, so yeah, I think we can safely say that's a double of WMOX. And yesterday I got a little bit of false hope for one of our AM stations. I tuned in to 670 and was hearing Petula Clark downtown, and I asked myself, are they finally dumping the black gospel format and switching to oldies? So I kept listening, and then the song was over, and all it was just a song that was being used by a black talk show host, and he was on there talking about all of the COVID-19 lockdowns. And so no, unfortunately it doesn't appear that they're switching to an oldies format, so there you go. Wish WMOX would do an about face, since all the talk stuff is basically moved to FM. Like I've said before, all they have is Mike Gallagher and that's Fox Sports crap. It's carried on another station in the afternoon. So I don't know why they don't do something like switch back to oldies, switch back to the music they played when they were younger. But then again, I know why they don't do it, because it would cost them money and all the royalties they have to pay. Okay, that's our little country station coming in, so I think about all that's left to do with this is maybe touch up the alignment. I really don't think it's going to be off that bad, and then call this one a day. One day I'll deal with this speaker, but not really too worried about that right now. I can just connect a better external speaker to it anyway.